So yeah, next week you've got your assignment 2 is due. And I'm gonna open up quiz 5 next week. I'm gonna give you lab 5 next week. And I'm also gonna open up assignment 3. So things are gonna get busier. Okay, and first priority is family. I hope you guys are all. I hope that you are physically well and mentally well. This is it. You know what I mean? You've got what, 3 weeks to go. Yeah, 3 weeks, and then you're into exams, and then the whole thing. So stick it out. 3 weeks. Keep at it. Emails have people are emailing me, but please, if I'm not getting as many emails, so either that means that you guys are doing okay, or people want to email me, but they're not. So, but please keep in contact with me if anything's going on, anything I can do to help. Family's number 1, so if you're having issues, let me know. But other than that, I think things are going all right. I'm going to try and no, marking is pretty much up to do. Everything should be all right. Let me know if any of the answer portals, if there's any issues going on with that. But I think everything is going okay. So you guys just keep at it. I'm proud of you. Keep at it. Hopefully there you like this stuff. Organic chemistry. It's more of a puzzle, but there still is quite a bit of stuff to know. But it is kind of a puzzle. The answer's right in front of you, and there is a systematic way of doing things. So if you guys don't have anything, I got nothing. We can go ahead. The best thing you guys can do for chemistry is try those questions there in the back. Okay, you guys have the answers there. Hopefully everyone has a copy of the book that you can siphon through and get the questions. Please just keep at it. You got 3 weeks. Don't you dare take your foot off the gas. Keep accelerating. Okay? And in a month, you can just slack off for the summer. Okay? And yeah. Other than that, we're going to go ahead. I'm going to share here. There's your PowerPoint there for this week. Okay. We're going to be dealing with unsaturated compounds. Basically. We're going to introduce some other things here as well. But you'll notice there that saturated and unsaturated. Last week there we did saturated. And saturated means full. Kind of has the same meaning as it did for solutions, but completely different meaning. Okay. Here we're talking full of hydrogens. So a saturated compound is a carbon-carbon compound with no double bonds. Again, saturated is a carbon-carbon compound with no double bonds. It only has single. Okay? So if the carbon only has single compound, or it only has single bonds, because carbon has to have 4 bonds to it at all time, that means that the other bonds there are hydrogens. Okay, you're full of them. There today, we're going to be just talking about unsaturated compounds. Now, these are compounds that have double and triple bonds in them. Is anything going to change as far as naming goes? No. Is still the most important slide this one? Yes. Okay, but you'll see here that there's a systematic approach to naming these things. And hopefully there you've had a look at the quiz. Hopefully there you've had a look at the assignment. And you'll see the assignment there is kind of a smackdown. And I apologize, but not really. Because I want to expose you guys to what the test will be like. And so let's have a look. Bit of review. Okay, so can you name these compounds? So, you have a look at these right here. naming these compounds. So the first thing you go, okay, is there any double, triple bond? No, it's all single. So when I'm trying to name these things, I always start from the back end first. You know, whether it's 2,4-dimethyl, pentane. I always start with the ane first. I always start with the back end first. So I see here that these are all single bonds. All right, so that's got to be an ane. Now, what kind of ane is it? I find my longest chain. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And be careful. Remember that single bonded, like all these right here in here, these are all single bonded carbons. There's no dubs or trips. So you've got to remember that all of these single bonded carbons and hydrogens that are coming off, these guys are rotating 360 degrees. All right, just because of the bond angles there. All right, and like just trying to picture, yeah. Now you see here you've got this carbon here, and this is written for ease. And you see I got 1, 2, 3, 4, 5. So this is a pentane. All right, ane, because there's 5. But I could easily make this my number 1 carbon. 1, 2, 3, 4, 5. I know it looks like right here it's a nice straight chain, but these things are not. Because they're single bonded, they're rotating in space. Remember we talked about that there last week. Okay, so I will try and write it so your longest chain is a straight line, but then I will also write it where it looks like your longest chain is a straight line. Your eye is going to go to that first, but no. You've got to find your longest chain of carbons, whatever that is. So you look at this one right here. My longest chain is 5, so I have a pentane. Hi, Shire, what's up? All right.
Water's not on.
You're right. Go for it anyway. I'll be there in a minute. Close the door, please. Thank you. Yeah, never fails. Never. Where was I? Blood toilet or pentane? Oof. I'll stick with the pentane, please. So, here we go. So here's my longest chain. And what I do is I draw a line through it. So that is it. Now what do I have coming off here? I've got a 1 carbon alkyl group. So this is a methyl. Where is that? On the 2 carbon. So it'll be 2 methyl pentane. This one right here. What do we got here? 1, 2, 3, 4, 5. So I got a pentane again. And I always start from the shortest side. So I got this methyl group. So 1, 2. This is also 2 methyl pentane. Same banana. Look at this one. 1, 2, 3, 4, 5. And this one here is not written in a nice form. This one here is demonstrating that these bonds are rotating. Expect to see it. This one here is also 2-methylpentane, and this one here is also 2-methylpentane. Okay? So I put this in here because these guys here are not isomers. You remember an isomer, the same chemical formula, C4H8, but they have completely different structures. And you'll see here that these are all the same. And you'll see my methyl group on top of, on the bottom here. You have to assume that this is going to rotate and that methyl group can be here as well. All right? And you'll see here that this molecule and this representation here, they are in fact the same thing. This one here has been flipped from left to right to right to left, and then put on top. Half the trick to these is just being able to see that three-dimensional rotation in here. And it's a skill. it comes quickly. You'll start to see it there before the end of the semester goes. Okay, so these are all 2-methylpentane. Any issues? Nah. Name this one. What do we got here? So write the structural formula for 5-ethyl 3-methyl. Now remember, generally we like the numbers to go in order, but sometimes they don't. You'll see here that this is 5-ethyl 3-methyl. E comes before M. So that's why we write that before that. But again, if I give you the name and I ask you for the structure, you do the same thing. Start from the back end. So, octane. So, 1, 2, 3, 4, 5, 6, 7. Wait a second. 1, 2, 3, 4, 5, 6, 7. Hold on here. I gotta go and check on something. Hi guys, I'm back. Very good. What do we got here now? Again, this is written like you'd think there that this is your main carbon chain, but be careful. 1, 2, 3, 4, 5, 6, 7, 8. So there's your octane. Some of these will be written and they're not nice. All right, and you've got to figure out what your longest chain is, and then start from the shortest end, which would be here. 1, 2, 3. There's your methyl. 4, 5. There's an ethyl. So 5-ethyl, 3-methyl, octane. A little bit of review there. Hopefully these are going well. Today we're into the enes and the ynes. Does the name follow? Does everything work out the same? It really does. Okay. But you're also going to see there today that there is going to start to be a hierarchy where if this is here, then we name according to this way, not this way. But if this is not here, then we'll name it according to this way. You'll start to see how it all goes. A little bit of review there for the reactions involved in alkanes. Okay. I made this little, I don't know, what do you call it? Pseudonym. All right. And SCARE. Substitution, combustion, oxidation, addition, reduction, elimination. And those were all in last week there. And you guys will have an open book test anyway, so you don't really have to remember this anyway. Let's go. Naming alkenes and alkynes, dubs and trips. Now, you have a look at this one here. And you'll remember there last week I said if you're going to put a number in your name, the only reason you're putting a number in there is because there's another number possibility isomer that exists. If there is no other place to put this, if there is no other isomer that exists, then you don't need a number. And you have a look here. Here I have, you do the same thing. You find your longest carbon chain, so it's 1, 2, 3, 4. Okay, this is a bute. Okay, single bond, single. Okay, I got a double bond here, so that's a butene. Now you got to tell me where that double bond is. Well, you go to the shortest side, and that's on carbon 1. 1-butene. This one here, 1, 2, 3, 4. It's a bute. There's a double bond, butene. 1, 2. This is a 2-butene. Doesn't matter which side you start from in this case here. They'll both be 2-butene. And then you see here, 1, 2, 3, 4. This is a bute. I have a trip. It's a butyne. Now, where is it? Carbon 1. All right. Branch chains now. Have a look at how these are named with a double bond in it. Okay. So, let's blow this up. First thing you do, find your longest carbon chain. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Wait a second. Hey, I got 7 carbons here. Here's our hierarchy. You find your longest carbon chain that involves the double bond now. Now you see the double bond now supersedes finding the longest carbon chain. So now you find if you see a double bond or a triple bond in there, your longest carbon chain must include that. So you see here, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So my longest carbon chain is 7, but it doesn't include the double bond, so I have to include the double bond. So 1, 2, 3, 4, 5, 6. So this is a hexene. Okay? Start from the back and work forward. Okay? Because you need that base before you need to know what your carbon chain is, which is your base, and then you need to find the groups that are off of it. So this is a hexene. And because I'm starting here, because that's where the double bond is, it's a 1 hexene. Okay, so I got that. So here is my chain. There's nothing else going on in it. So on the 1, 2, 3 carbon, I have a propyl group. Meth, eth, propyl. So this is 3 propyl, 1 hexene. Any questions on that one? Am I on mute? I hope not. Return to meeting. All right. Let me know if there's any issues. This one here, find your largest carbon chain, and you'll see there that there's a trip. So 1, 2, 3, 4, 5, 6. Now you could very easily go 1, 2, 3, 4, 5, 6. It doesn't matter. Okay? Because remember, these bonds are rotating here or here, and even this methyl group can be up here as well. This one as well. They can be anywhere on these single bonded carbons. Not so for doubles and trips. This is huge important, which I'm kind of foreshadowing. I've got 10 slides on it later. But only with single bonded carbons is there this idea of free rotation. Okay, that's why we can write them, find your longest carbon chain. Okay, got it, 9. But double and triple bonded carbons, there is no free rotation. Those double bonds, they lock those 2 carbons in. So it's almost like this planar sheet. It's flat, it's kind of 2-dimensional, and it's locked in. We'll get into more of that there later. But so we find out here that this is 2-hexyne. 1, 2, 3, 4, 5, 6. Triple bond is on the 2. So there's my 2-hexyne. And I have 1, 2, 3, 4 methyl and a 5 methyl. So 4, 5 dimethyl 2-hexene. And you'll notice there that if there wasn't a triple bond here, if this was just a single carbon, I would start counting from this side. 1, 2 methyl, 3, so it would be 2, 3 dimethyl hexane. But because we've got this, our entire numbering system jumps to the closest side of the triple bond. Okay? And also, remember, if you're going to put a number there, there should be another isomer with another number as well. All right? So, let's move on. So, we're just going to introduce some functional groups, and that's what we call them, functional groups. Carboxylic acid, amines, amides, esters, ethers, alcohols. And you right here, this is what goes into a cocktail. All right, this is ethanol. And you see 2 carbons, eth, single bond, ethane. All right, there's an alcohol group on here, OH. All right, so this is ethanol. Would you write 1 ethanol? Well, if you write 1 ethanol, then there's got to be a 2 ethanol. And so a 2 ethanol would be this alcohol group on this carbon. So you'd have it over here. But really, wouldn't you just have the same molecule in 3-dimensional space? Okay, so in this case here, 1 ethanol is the same thing as 2 ethanol, so there are no numbers. See what I mean? That's when you don't use any numbers. Okay, so this is just plain old ethanol. All right. I'll be back. Sorry. Come on, Harley. Get out of here. All right, we're back. There we go. Let's go. Sorry, that's what you do there with kids, right? Shire, get it done. So here we have ethanol may be written as this or your
shirt too.
All right. There you go. Put your shirt on. There you go. Numbers forward. There you go. Bye-bye. Close the door, please. There we go. Shire, close the door, man. Thank you, buddy. Okay. You have to be able to see how these are written and the condensed structural formula. You will notice that any alcohol there, all, O-L. What we got here? You're going to see primary, secondary, and tertiary. You're also going to see this there for amines. And again, we'll deal with this there when we get into more into alcohols, but it's all about foreshadowing. That's all I'm doing there today. A primary alcohol is an alcohol bonded to a carbon, okay, that's not bonded to any more carbons. A secondary alcohol is an alcohol group bonded to a carbon that's bonded to 2 more carbons. And a tertiary alcohol is an alcohol bonded to a carbon that's bonded to 3 other carbons. Why is this important? It'll affect the chemistry, and it'll affect the chemistry big time. Primary, secondary, tertiary alcohols. All right. That's all I'm going to leave. I'm going to just kind of talk about that for right now. You'll see that again. I promise. I just kind of throw things in there so that next week there you'll see them again. Alcohol naming. Now you have a look here. You do the exact same thing. Find your longest carbon chain. Well, 1, 2, 3. So this is a prop. Any dubs, trips? Nope. Propane. Now I've got an alcohol group on here. Propanol. Now, do I put a number or do I not? Well, I can have an alcohol on the 1 carbon. Can I have an alcohol on the 2 carbon? Yes, I can. Can I have an alcohol on the 3 carbon? Well, that would just be 1 propanol. Okay, so in this case here, you have two isomers of this. Okay, you can have one propanol or two propanol. In this case here, there's your 2-propanol. That's what that one looks like. Have a look at this one. Now, this one here, I won't talk about it too much, but you're going to see this there towards the end of the presentation here. But find your longest carbon chain. 1, 2, 3, 4. So this is a bute. I've got a double bond. Okay, so this is a butene. All right. But wait a second. I've got an ene and an alcohol group here. Which one trumps the other one? Which one's the big boss? Well, when you have these two here, the functional group, the alcohol group, is now the big boss. So that'll be an all. All right. Where is the alcohol group? It's on the 1 carbon. Okay. And then we have 2-butene. That one there's a bit of a strange one. I thought I would throw it in there. Okay. 2-butene 1-all. So the 1 is talking about where the alcohol group is, and the 2 is talking about where the double bond is. Okay. Now, looking at this as compared to one of these guys up here. These molecules there, alkanes, they're all free rotating. Okay? Like this right here, this carbon has a hydrogen here, and an alcohol group here. Well, that's just how we're writing it. But this alcohol group could be down here. The hydrogen that was here could be over here. They're all rotating around this carbon that's singly bonded. Singly bonded. That's not even a word, Ian. All right. But have a look here at my double bond. There is no rotation here. So this is kind of like a flat, solid. Those carbons, there's nothing rotating on them. That double bond is locked. A triple bond is locked. There's none of this free rotating. So this hydrogen here is there. This methyl group is there. Nowhere else. These guys are not rotating around each other because the double bond is locking them in there. You see this methyl group here with an alcohol? It's in the top right-hand corner. This hydrogen is in the bottom right-hand corner. And you'll see here that we're going to play with this a little bit there later. All right? We'll come back to that. This one here, I have 3-methyl-1-butanol. Find your longest chain. 1, 2, 3, 4. There's a butane with an alcohol, butanol, 1-butanol, and then 1, 2, 3, 3-methyl-1-butanol. That's how those work. If there's any issues on those, just email me and we'll get them all cleared up. Okay? I don't think there's any alcohol naming on the assignment. There will be on assignment 3 there next week, but I think the assignment is just anes, enes, and ines. I think there's some benzene in there as well. Amines, this is another functional group. It's NH2. Okay? And it works kind of the same way as alcohols. There's a primary, a secondary, and a tertiary. And you'll see here that this is methylamine. So you'll see there that amines there, they take the name amine. And I have 1 carbon, so that's a methylamine. Okay, where the amine is attached to a single carbon by itself, primary. Here, amine can be attached to 2 carbon chains. This is what we call a secondary amine. And here, the amine, all of its hydrogens are gone now, okay? Because nitrogen has an oxidation number of -3, so it can make 3 bonds, okay? And you'll see here that this is a tertiary amine. trimethylamine, dimethylamine. We'll get into amines there. I think it's week 11, I think. All right. So this one here, now again, I introduced these there last week. I'm giving a little bit more information there this week, okay, on these guys here. We will continue on week 10, 11, and 12, okay, on these. All right. There are two functional groups, aldehydes and ketones, that deal with this. And this right here, C double bond O, is what we call a carbonyl group. That's it. Carbonyl. Whenever you hear or see the word carbonyl, it means C double bond O. Okay? And so you have a look here. You have aldehydes have the carbonyl group on the end. Ketones have the carbonyl group in the middle. So let's just break this down. If you see this, if you see the letter R, that just means an unknown, who cares chain of carbons. Doesn't matter. It's not important for what we're looking at. So here I have all these carbon groups, could be 1 to 1,000,000, doesn't matter. But here at the very end of the molecule, I have C double bond O to an H. Bang. That's an aldehyde. Okay? And if you look at the naming, it's still the same. Find your longest carbon chain. So here of the example, I have 1 carbon and 2 carbons. So this is an F. And they're single bonded, so it's an ethane. Ethane. And then I have this aldehyde group on the end, this carbonyl group. So this is an ethanal. That's it. Okay. If you look at the ketone, here I have some carbon chain. Here I have another carbon chain, not important. But in the middle of these 2 carbon chains, I have a C bonded, double bonded there to an O. That is a ketone. All right. And again, the same naming. You have a look here. Find your same longest carbon chain. 1, 2, 3. So this is a propane. And I have a C double bond O in the middle here. So I call this propanone. That's how it goes. Interesting question. Why is there there is no number on this? Why? Because if there's a 2-propanone, there's better be a 1-propanone or a 3-propanone, right? Well, what would happen if I put this double bonded O, if I put it on the end, right here? Or if I put it on this end? What would happen? It would turn into an aldehyde. Let me say that again. This is propanone. Okay, 1, 2, 3 carbons, all single bonded. Here I have this ketone in the middle. All right, so this is propanone. If I take this carbonyl group and throw it on the end, you wouldn't have a ketone anymore. You would have an aldehyde. All right, so that's how these guys are related. They're kind of the same banana, but an aldehyde has got the carbonyl group on the end. And a ketone has the carbonyl group in the middle. That's the trick. So this is ethanal, propanal. This would be propanone. Good question is, would you ever see an ethanone? Figure that one out. Why there's no such molecule as ethanone. Anybody have a question on that? Let me know. Good little question there to make you think. Another functional group there that contains the carbonyl group, the C double bond O. Write that one down. You'll see that again. Is the carboxyl group, carboxylic acids. Okay. Generally weak organic acids, oxalic acid, acetic acid, all these type. All right. And you'll see here that these happen on the end. There's no carboxylic acid group in the middle. These are always at the end of a carbon chain somehow. And it's C double bond O, and the same C, there's an alcohol group on it. So there's a lot of oxygen on the end of a molecule here that has a carboxylic acid. Oxygens, number 2 on the list for aggressive atoms. So this thing is pretty reactive in some sense, okay? Because you got a lot of oxygens in a confined space on the end of a molecule. Very negative, all right? Generally, these guys will go into water pretty well for a certain number of carbons on their chain, but we'll get into that, okay? So these are these carboxylic acids. Amides, all right? These are peptide chains, peptide bonds, okay? And you'll see there that amino acids, very, 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 very small molecule, right? Basically 3 carbons. And on one end, you'll have a carboxylic acid group. On the other end of an amino acid, you will have an amine group. Right here. So, what happens is you have a carboxylic acid negative group on one side. You have an amine group positive on one side. So basically what makes these amino acids so awesome is they have an acid on one side and a base on the other. So, and what happens is the bond formed when you join these amino acids together there in the ribosomes, okay, where they're making polypeptides, is you get this bond. See, you have some R group carbons on one side. You have something going on this side, whatever. But then you see here, when you get, when these amino acids come together, okay, you get this C double bonded to an O bonded to another nitrogen. So this is what's called your amide bond. Don't worry, you don't have to know this now. I'm just throwing stuff at you. Hopefully 40% of it sticks because we're coming back to it there in 2 weeks anyway, okay? Just foreshadowing. Esters. All right. These guys here also deal with the carbonyl group. Okay. These guys here, very smelly, fruity. You know, you can actually isolate the compound, the ester there that is responsible there for banana. You know, there's a really good lab there that we do in pre-health that we're not doing now. It's the ester lab. And where you guys make these in class, and this one here smells like strawberry, this one here is apple, this one here is pear. There's one there that is, it's quite crazy actually. It's it makes Parmesan cheese smell. And it's very intense, and the whole lab smells like Parmesan cheese there for the next couple of weeks. And oh yeah, it's interesting. I don't eat Parmesan cheese anymore. And so this is your ester. We'll get there. I'm just kind of throwing stuff at you right now. There's ethers. Okay, these are just carbons with an oxygen in the middle. Okay, and we'll get into more naming here. You'll see here I have old school names on top. I put the real name on the bottom. You'll look at this one here, F-oxyethane. So oxy is the IUPAC way of dealing there with ethers. So you see I have an F12 and an F12 on this side, so it's F-oxyethane. You have a look here, 1, 2. Okay, and then I have 1, 2, 3. I have a propane group on this side. I have ethoxy, 2-propane. This one here, I have methoxypropane. We'll get into that. We'll get into all of this stuff there later. Just throwing stuff at you. We still got lots to go here. Halogenation. So can you name these? What would be the name of this one? Now, carbon chain, 1, 2, single bond, ethane. So now I have bromine and bromine. Where are they located? 1, 2, dibromoethane. Hopefully there that makes sense. This one right here, I haven't taught you yet. Last week there we did a cyclohexane. This, please make a note, this is not cyclohexane. If it was cyclohexane, it wouldn't have this circle in the middle. I'll explain what that circle is. This is benzene. It's a different banana. It's a hydrocarbon, but it's completely different and it gets its own category because it's that odd. It's very stable, occurs naturally in, earthly processes. It's there, but it's very different. If this was cyclohexane, 1, 2, 3, so 1, 3 dichlorocyclohexane. But again, this is not. This is benzene. This is going to be a little different. Okay? Introducing benzene. Also called an aromatic because it's pretty dangerous stuff. It's benzene by itself is carcinogenic. There's actually what is it? It's a compound there found in apple seeds and these kinds of things. It's got cyanide and benzene linked together. And by itself, it's not bad. But what happens is if you eat enough of this compound, which is found minimally in seeds, like you think you'd have to eat a truckload of apple seeds in order to get sick. But what happens is this compound goes into your stomach if you eat a seed and it snips it. So now you've got cyanide and benzene both in your tum-tum. And but what's going on here as far as benzene and what makes it different is you have 6 carbons. Now, carbon has to have 4 bonds. That's carbon. There's no other way around it. But have a look here at what's going on. You'll see how it's written here. There's a circle in here, but really what's going on is if you have a look, I'm just going to move this out of the way a bit here so that we can see this. And 6 carbons. There's a hydrogen on each of the carbon. So that's one of the 4 bonds taken care of, right? So each carbon still needs 3 bonds. But you have a look here. Benzene can exist in either of these states. So when I write it like this, you see there's a double bond here, single. Double bond, single, double, single. So you see every carbon has 1, 2, 3, 4 bonds. 1, 2, 3, 4. And this carbon here, 1, 2, 3, 4. So everything's taken care of. But it seems a bit lopsided. And what happens is these double bonds, they're what we call pi bonds. And they rotate. They jump from here to here to here to here to here to here. So at any given point in time, you'll see that, look, the double bond is here, here, and here. But at any given point in time, it could also be here, here, and here. So they're rotating. These pi bonds, these double bonds are rotating. I mean, like at 1,000,000 times a second, right? And we call this resonance. Write that down. Resonance. That the same molecule can exist basically in both states at the same time. All right? And that's why we write benzene like this. So if you ever see a hexagonal shape, which you will between now and week 13, and if you see a hexagonal shape with a circle in it, ding, 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 that's benzene. That's aromatic. Whoa, different chemistry. Stop the presses. Okay? If you see a hexagon without a circle in it, that means it's cyclohexane. It acts like an alkane. It's different. Okay? All right? Just to be clear. And just to, didn't mean to scare you there about benzene, but it exists in all sorts of things. Aspirin, wintergreen, that's a good one there we make in the lab. Vanilla, and TNT. Absolutely. Trinitrotoluene. All right? And so benzene is a part of our everyday, and it's okay. Just pure benzene, 100% benzene. Very nice. It has this smell, all right, and not good at all. Now, naming benzene. You will see in the same folder I've included this, because since chemistry was, discovered before me, other people, how dare they created their own naming systems without consulting me. And benzene there, we're going to use some new school and some old school. That's just the way it goes. Okay, so I've included kind of a little naming chart here, which we'll go over there at the end. Okay, just so you guys aren't left in the lurch. But there are some interesting things that can go on as far as naming goes. So you have a look here. Add the name of the substituent as a prefix to benzene. So here we have nitrobenzene. Easy peasy, right? Here we have ethyl benzene. And that should make sense now. Right? See, it's just the whole process of learning. It takes, and then you build onto it and you build on it. That's knowledge acquisition. Have a look here. Chlorobenzene. Bromo. No numbers needed, right? If I put the bromo on this one, that means I've just tilted the entire benzene over like that. So it's still bromobenzene. Some have special names, okay? Like this one here, we could call it methylbenzene. Bingo. But you might also see it as toluene. So that's an old school name that's still used and still relevant. So while this one here is ethylbenzene, this one here is methylbenzene, but it's also known as toluene. This one here, hydroxybenzene, or we would call it phenol. You're going to see that sometimes we use the benz, or we could also refer to benzene here as phene, like a phenyl group. And you look here. Here we have toluene methylbenzene. So you can see there that the benzene is the big boss. The methyl is hanging off of the benzene. Well, you have a look here. Phenol. Who's the big boss? Is it the benzene or is it the alcohol? Well, there's an all here, so the alcohol is trumping the benzene. So in this case here, it's phenol. All right. Is there a rhyme and reason to this? There is, but this you will see, you will hear things in the medical field. You won't really hear hydroxybenzene. You'll hear phenol. Okay. This one here. Here I have a benzene with a carboxylic group hanging off it. C double bond O to an OH. Benzoic acid. Here I have aminobenzene. Be careful. People get amino and nitro mixed up. Don't. Okay. Nitro is NO2. This will be the first time you've seen that one. Okay. Amine is NH2. All right. But this one here also has a special name, aniline. Why? Somebody made the system before I did. Where are the functional groups on the benzene? We can still use the numbering system. 1, 2, 3, 4, 5, and 6. Okay? But there's another naming system for benzene. And only for benzene, not for cyclohexane. And we use ortho, meta, and para. And they're pretty easy. You have a look here. Here I have a benzene. I have dichlorobenzene. 1, 2, dichlorobenzene. We could also write that as ortho dichlorobenzene. Ortho just means that these two bananas are side by side on the 1 and 2. Okay? Ortho just means side by side. Here I have the same banana, but now my chlorines are on 1 and 3. So this is 1,3-dichlorobenzene or meta-dichlorobenzene. And this one here is para, 1,4. So you don't use 1,4-para-dichlorobenzene. You use 1,4-dichlorobenzene or para-dichlorobenzene. Either one means the same thing. Okay? And you'll see that they are different bananas. Look, melting point 17.2, boiling point 180. Melting point 24.8, boiling point 172. Okay? They're different bananas and they need to be written that way. So you'll see para-dichloro or you'll just see P. Okay? Like a good question will be, which of the following is meta-dichlorobenzene? And I'll give you 4 pictures and you'll have, okay, this one, okay, 1 and 3, this is the one here. C, correct answer. That's how that one will go. Okay? Isomers of benzene. Okay, if we replace 2 of the hydrogens on benzene with chlorines, we have dichlorobenzene, of course, and same banana. Okay, so these are isomers. Isomers, same chemical formula, different structure, different melting point, different boiling point, different densities, different properties, different everything. Okay. Naming disubstituted benzene. Okay, now there's a bit of a hierarchy. Okay, so you look at this one here. Here I got a benzene. Okay, here I got an alcohol group. And here I've got a nitro. Alcohol will trump the nitro. So again, start from the backside. So here, if I just look at the benzene and the alcohol, this is going to be phenol. And the nitro is right beside the alcohol group, so this is going to be ortho. So ortho, nitro, phenol. Or it could be 1, 2. Okay? Or sorry, 2 nitrophenol. That's what we're looking at. This one here, it's para. Now I got bromine and amine. So this is going to be p-bromoaniline because this guy here has its own name, aniline. And you don't have to remember these. You just have to be able to find them on the chart there that I've given you. Okay? They've got them all here. And we can go through them. There's benzene, chlorobenzene, nitro, iodo, methylbenzene. What's the other name there for that one? Toluene. I think it's written down below. Okay? So it's methylbenzene, toluene, ethylbenzene. Look at this one. Chloromethylbenzene. Here the chlorine is not on here. It's a part of the methyl group. All right. Aminobenzene. And what's this one? Aniline. I think that's written down below. And these are all just different examples to help you with your naming here. So here I have 2-chloromethylbenzene. Okay? Or orthochloromethylbenzene. Here I have meta-chloromethylbenzene, and here I have para. Okay? Isopropylbenzene. Iso just means the middle. So you look here, isopropyl benzene. So here I have propyl. I have 3 carbons. 1, 2, 3. But where is that carbon attaching to the benzene? In the 2 carbon, which is the middle. So it's an old school name. You could probably say 2-propylbenzene. What do we got here? 2-methyl 1,3,5-trinitrobenzene. All right. And you could just have a look here at what's going on. 1,3,5-trinitrobenzene. You could actually play with this, and this could be toluene. We'll get into it. Old school names here. Benzoic acid. This old school name is only used, so there's no other name for this. Benzoic acid. And you have a look at this one here. Here I got a benzene with a chlorine with a carboxylic acid group on the end of it. All right. So, meta, because you see how it's 1, 3. And be careful, you're not counting clockwise. You're counting the shortest distance in between both of them. Okay, so if this is your number 1 carbon, you don't go 1, 2, 3, 4. Go your shortest route. Think 3-dimensional. Okay, 1, 2, 3. So this is meta-chlorobenzoic acid. Make it make sense. Okay. Here we have an aldehyde group. Benzaldehyde. Okay. What do we got here? Here we have a benzene group. 1, 2, 3, 4, 5, 6. What? We got a hexane group on here. Hexyl benzene. All right. Some of them there we use phenol to name. And in this case here, when we use phenol to name, it's kind of really, this guy, the benzene group has moved from the primary to kind of like a side group. So here we have phenylethene, phenylethanone. Look, here I have, it's a ketone in between. Here I have phenol. Look at this one here. Here I have, here's my phenol group. And on the 2, 4, and 6 carbons, I have 3 chlorines. So it would be 2, 4, 6 trichlorophenol. See it? Make it make sense. And I'll be around after, so if any of you guys, if any of these ones here aren't making any sense, we can make it make sense. Here's a, if you'll see oxygen, and right underneath it is sulfur. Sometimes they kind of act the same, and we breathe oxygen. 99% of all creatures on Earth there breathe oxygen, but there are a couple of bacteria that live at the bottom of the ocean that they breathe sulfur. Ugh, bad stuff. Rotten eggs all the time, right? But sulfur and oxygen can kind of act. They both have an oxidation number of -2, so they can facilitate in different ways as far as breathing and respiration goes. So in this case here, this kind of acts like an OH group, and this is called a thiol group. So here we have thiophenol. And you can go through these here. Look, we have methoxybenzene, there's an ether, and all these. Have a look at all these, and you've got them there for a test, a quiz, and assignment, so nothing is being hidden. There's naphthalene, 2 benzenes there together. So have a look at these. Do you have to memorize them? No, they're there, but you have to be able to find out. Because the thing with benzene, sometimes it could be old school, sometimes it could be new school, sometimes you're using benzene, sometimes you're using phenol. Okay? And I'm not asking you guys to be experts by any means, but I am asking you guys there to be able to refer to any of the sheets there that I've given you. Is good? All right. If you guys have any questions or comments, I can't see. I have the dialog box closed, so let me know. Scream out and say, hey, and it's not making any sense. Naming polysubstituted benzenes. 1,2,5-trinitrobenzene. That's trouble. Why is that a problem? Should be 1,3,5. Okay? So 1, 3, 5. And there's 3 of them there, so you've got to put a tri. No doubt about it. If there's 2 there, you got to put a di. Check out this one. Carbon tetrachloride. Maybe if you have a pen and paper. Carbon tetrachloride. What does that one look like? I'm not telling. What do we got here? 1,2,4-tribromobenzene. Okay? And you could start counting from everywhere. But you have to start counting that will give you the overall lowest numbers. So if you started counting here, so there's 1, 2, 3, 4. So 1, 2, 3, 4. So 1, 3, 4 tribromobenzene. It's wrong answer. 1, 3, 4. If I start counting from here, 1, 2, 4. So that's where you start counting from. Be careful where you start counting because you want the lowest numbers that you can get. And it all depends on where you start counting. All right. Here you have your benzene with a methyl group. So this is methylbenzene, but it's also known as toluene. And this guy here is on the 1 carbon. So I have 2, 4, 6 trinitro-toluene, which is boom, boom, TNT. Okay? It's all new, but again, you don't have to memorize this stuff. You just have to be able to find it and recall it. But you guys are a good group. The class average, I think, is 80, 78. You guys are banging it out. Keep at it. So let's practice here. Name this compound. Oh, the name is right there. So I have benzene, I have a chlorine, and here I have an ethyl group. So you'll see there, ethyl, chloro, meta, B. Isomers, same atoms, different structures. And you'll see there, the more we get into, like next week there, we're going to start hitting functional groups. I'll break them up into sections, okay? And we're going to whack them out because there's different reactions that, like an alcohol will be, if it's primary, secondary, or tertiary, which I introduced at the start of the lecture, which you probably forgot already, but the whole point is that you are kind of familiar with a primary, secondary, and tertiary alcohol, which we'll cover more next week. Their reactivity changes. All right, but we'll get into all that kind of stuff. You have a look here. Here I have propanal, aldehyde, and you'll see here I have propanone, which is a ketone, which they're very similar and they have very similar characteristics, kind of. All right, but an aldehyde is a ketone on the end, and this ketone there is in the middle. All right, but they are isomers of each other. C3H6O. What do we got here now? Aha! Now we're back into alkenes there. I just had to sidetrack for a little bit. You see what's going on here? You guys have seen these pictures there kind of before. I forget what slide it was up there towards the start of the group, or sort of at the start of the presentation. Now, cis and trans isomers. This is only for alkenes, double bond. And when you see how these guys here are kind of written like an X, there's a reason why I've written them like an X, is because you're going to have to tell me if this is cis or trans isomer. Now, isomer, same thing as what we just had up here, same chemical formula, different physical structure, right? Different properties. Well, have a look here. Here I have, what is the name of this? You can see there, it's a 3-hexene. Well, let's try it out. I got, find your longest carbon chain. 1, 2, 3, 4, 5, 6. So this is a hex. There's a double, so it's a hexene. Where is my double? 1, 2, 3. And if I want to do it from this side, 1, 2, 3, it doesn't matter. So this is a 3-hexene. You're not done yet. Because remember, these double bonds, there is no rotation. So this group is up here. This group is in this quadrant. No, this group does not float down here, and this hydrogen doesn't come up. Not with dubs and trips. All right? But cis and tran is only for alkenes. Doesn't exist for alkynes. But you'll see here, cis means the same side. Trans means opposite side. So you have a look here. My hydrogens, they're on the same side. Okay? This mess over here, these guys are on the same side. So we call this cis 3-hexene. Whenever you see these molecules with a double bond written like an X, I'm looking for cis and I'm looking for trans. And then you see here for this one, same molecule, but these guys here have been inverted. So now this hydrogen is up in this corner, opposite this hydrogen. This guy here is opposite here, so this is trans 3-hexene. Okay, that's the only thing. And you'll see here, that's how you want to deal with this. So whenever you see an alkene, not an alkyne, they're not involved in cis and trans. So whenever you see an alkene written like an X form here, this is what I'll be looking for. Okay? And the cis and tran isomers, there's no rotation around the double bond in an alkene. The groups are attached to the double bond and they're fixed. And here just you can kind of do it there with your hand. Cis, okay, both thumbs are on the one side. Trans, okay, when the thumbs are on the other. That's how that one works. So you look at this one right here. And my longest carbon chain is an F, 2 carbon, ethene. Okay. Now, what's going on here? I got a bromine and a bromine, so that's going to be, is it 1,1? No, it's 1,2 dibromoethene. 1,2 dibromoethene. Now, you'll see here that the bromines are on the same side, the hydrogens are on the same side, so there's going to be cis 1,2 dibromoethene. And then you'll see here, this one here will be trans 1,2 dibromoethene. Let me know if there's any issues with that. I think once you guys do 1 or 2 of these, you guys will be fine. Naming, you have a look here. Here I have cis 1,2 dibromoethane. Okay, here it looks like you've got trans 2-butene. And then you have a look here. What is happening here? Here I've got 1, 2, 3. So that's propene. And the double bond is on the 1 carbon. So that's 1 propene. Start from your back and work your way forward. Okay, so I got 1 propene. But then I have 1,1 dichloro. Okay, so I have 1,1 dichloro, 1 propene. But is it cis or is it trans? What happens if I switch these chlorines? Nothing's going to happen, right? Because I got 2 chlorines. If I flip them like that, I'm still going to have 2 chlorines. So in this case here, there is no trans or cis needed. Be careful. Okay? Almost done. Which of the following is not able to exist as cis and tran? Okay. Great question. Irritating question because you'd have to draw them all out. And no other way to do it. Okay. What is the relationship of these compounds? Have a look here. 1, 2, 3, 4. Cis-2-butene. This one here, 1, 2, 3, 4. Trans-2-butene. Okay, so this whole stick thing, that is chemistry. Lazy chemistry, all right, but it is there. Okay, good question. We're basically, that's the, there's a couple things here. This is more vocabulary. There's a couple of words here that I want to explain. You have a look here, and have a look at these two molecules that I've put up here, and you'll see here that basically what I have is a mirror. Let's call this a mirror. And I put this molecule up to the mirror, and in the mirror I see this reflection. Well, you see here I have a hydrogen up at the top, a hydrogen up at the top. The atom closest to the mirror is a chlorine. The atom closest to the mirror over here is a chlorine. Okay, then I have an iodine here. So are these this, and I have a bromine. Is this the same? Are they the same? And no, they're not. They're isomers because the hydrogen is in the same spot. But then look at this one right here. From going right to left, I have chlorine, iodine, bromine. Chlorine, iodine, bromine. Chlorine, iodine, bromine. Well, let's do the same over here. Hey, chlorine, iodine. No, it's reversed. Chlorine, iodine, bromine. It's going counterclockwise. Okay, so this particular isomer only happens when you have 4 different bananas coming off of a carbon. And you'll see if you have 2 of the same bananas, like a hydrogen here, it's not going to work. Whenever you see a carbon with 4 different substituent groups on it, you have the possibility there for chirality. Okay? These guys here are what we call enantiomers of each other. Okay? They are mirror images of each other, and they're so close to each other that they have the same chemistry, they have the same melting point, they have the same boiling point, they have the same physical properties, everything except one will polarize light and one will not. That's the only thing. And it's part of what we teach here. Is it a big part? No. But I want you to know what an enantiomer is, and I want you to know that they have chirality. They're able, okay, they have their own orientation to them. All right, let's continue on. And this is called stereoisomers. Stereoisomers have identical molecular formulas, but they are not the same. Stereoisomers, the atoms are bonded in the same sequence, but differ in the way that they're arranged in space. And you'll see here that if we went from right to left, chlorine, iodine, bromine, it's not the same on this side. And here it's going from left to right. When stereoisomers have mirror images that are different, they're basically said to have left and right-handedness. Okay? Here I have my right hand, left hand. Are they the same? No, but they fit on a mirror, but they're not the same, right? Chirality and superimposability. Your right hand and left hand are mirror images of each other. The left hand and the right hand are not superimposable. I can't put one on top of the other. Because look, I got a thumb on this side and a thumb on this side. It ain't going to work. Therefore, your right hand and your left hand are chiral objects. Some everyday chiral and achiral objects. Gloves, chiral. Golf clubs, chiral. Football, achiral. Scissors. I couldn't imagine. I don't know. I know that on The Simpsons there, Ned Flanders opened up a left-handed store. I've never seen one or heard one, but I guess they do exist. And I don't. Is it 15% of our or 20% of our population is left-handed or something like that? And if you've ever tried to use a pair of scissors with your other hand, it doesn't work. And you guys can have a look at that. Chiral or asymmetric carbon atoms. Again, this particular situation only happens if you have 4 different bananas coming off of a carbon. Okay? Only this, 4 different groups. And what happens here? These enantiomers are optical isomers. Sorry, I missed that, Jennifer. I'll get back to it in a second. So these enantiomers are optical isomers. So they're not the same isomers as we've been talking about there before, with the same chemical formula but different physical properties. These 2 bananas are the same in every capacity, except one is rotated this way and the other one is rotating this way. That's it. So everything's the same except for the way that they conduct light. Unpolarized light that we see consists of the electromagnetic waves vibrating in all directions. So it's just mashed potatoes. All right? Ordinary unpolarized light. But when ordinary light passes through a polarizer or a chiral solution, zoom, straightens it right out. Okay? So that's the only way that we can really tell. Enantiomers have chirality, meaning they can polarize light. Okay, ability of a substance to rotate light can be right or left-handed. Chirality, a necessary condition for optical activity. Chiral objects or chiral molecules are mirror images and do not have a plane of symmetry. Okay, so here, this is just to kind of explain the same thing. Okay, there's this right-handedness, and it doesn't work on this side. They're not superimposable. But remember that if you have 2 different atoms on here and 2 of those are the same, okay, there is no isomer anymore. They're the same thing. Okay? And because I can rotate this around to look like this. So it has to be 4 different atoms coming off of a carbon. And identify each as a chiral or achiral compound. Well, easy peasy. Go to your central carbon. Okay. Chlorine, hydrogen, ethyl, methyl. 4 different bananas. Chiral. Next question. Here I got this one. Here I got chlorine, hydrogen, methyl. Achiral. Easy peasy. I got 2 here that are the same. I do not have 4 different bananas coming off here, so that's it. Achiral. Here I got chlorine, hydrogen, bromine, and methyl. We're back to chiral. All right? Because I got 4 different things. That's all I got there for today. I'll post the video there to YouTube in 10 or 15 minutes. Make sure my son, I'm worried he hasn't bothered us in half an hour. But anyway, that's all I got there for today. That'll be enough there to get you guys through to the assignment and the quiz. And I hope you guys are doing well. And I wish I could see you and assist better. But please let me know if anything is bothering you. Let's get on it now because we have time. Okay? Time is going to get it's going to crunch next week. And Abigail, you're awesome. Just keep going. Keep asking questions. I believe in you. Rock it out, man. Catherine, thank you. You stick around if you have any questions. Sounds like just too painful seeing with them. Oh, now I get it, Jennifer. Thank you so much. Yeah. Cheers, guys. You guys have a great day. The second figure is not cycling. It's benzene. All right. I hope you guys are good. Take it easy, and we'll see you soon. You guys have any questions? If you guys got any questions, let me know. If not, take it easy. Okay. I am going to stop.